Hello, Abdul. I am audible. Please just confirm me whether I'm audible or
Yes,
not.
sir. Yes, sir. Yes, sir.
Okay, okay. Let us wait for 5 minutes. Then we'll start. Maybe another
Okay.
participant will join. Okay. Let us wait
Okay.
5 minutes. Okay, let us start. So the week 6 content I have already recorded and uploaded. So please hope you all visited. Okay. So today we'll start with the week number 7. Week 6 content was recorded, so I have uploaded. Actually that day I was have very bad network. So due to this problem, due to the network problem, actually I was unable to take the class. But today will I am audible. Please just confirm me. Anybody can write yes. I think I am audible. Hello. Hello. Abdul, I am audible. Just please confirm me.
Yes, sir.
Okay, okay. Okay, so let us start. The first question is the gradually varied flow are example of first option is laminar flow, compressible flow, non-uniform flow, none of the above. So which option will be correct for question number 1? So please everyone you write your answer in the chat box. Very basic question from gradually varied flow. So please everyone write. The gradually varied flow. In week 6 video, I have actually discussed the classification of flow also, uniform, non-uniform, and steady, non-steady, 1D, 2D, 3D. So a lot of concept I have discussed in the week number 6, the fundamental concept of your open channel flow. But here is the, I think, a little bit ahead with fundamental. So the question 1 from the gradually varied flow. So everyone please write whether it is here name as a name suggests varied flow. If you will see very carefully, then you very easily you can write your answer in the chat box. Please everyone write your answer in the chat box. Very easy question. Okay, so let me just discuss a little bit. So here we are talking about the gradually varied flow. Actually, we have the two uniform and non-uniform flow. Uniform and non-uniform. So uniform flow means let us suppose a channel. This is the bed of the channel and this is your water flow depth. So let us suppose the water flow depth here is y, here is also y, here is also y, everywhere y. At a particular time, let us suppose 10 a.m. everywhere y. Such type of flow is known as, that is with respect to, if distance is x in this direction, is constant, uniform flow. But if the flow is like that, here is like that, something like that. Here is y, here is y dash, here is y double dash, here is y triple dash. So like that, as you are moving in the x direction, your depth change, that is depth not constant with respect to space or with respect to length. So that type of flow is known as non-uniform flow at a particular time, remember please. But here the question is about the gradually varied flow. So actually non-uniform flow have two types. One is GVF, gradually varied flow, and RVF, rapid varied flow. Gradually and rapid varied flow. So gradually varied flow means what? Your whatever the depth is changing, it changes for a long distance. Changes whatever you have seen here, the change, that is y to y dash, y double dash, is very gradually changing. So that type of gradually varied flow. A rapid varied flow means what? Let us suppose here is one gate is, and water is here, water is like that. Here is the depth is very less, here depth is increasing within a short span of distance, the depth varying much from this level to this level. So such type of flow known as rapid varied flow. Always remember please. So the answer of this question is non-uniform flow. Gradually varied flow is non-uniform flow. Hope you all got it. Now let us move on the, oh sorry, 70. Hello student, please wait few minutes. I think the network is not working. So just I have joined with my mobile. So please wait. I am trying to connect. I don't know. Okay. So hope everyone got it. The question number one. If you're not able to, whether you are got getting or not, let me open the video. Yes, please. Whether you all able to understand or not. The question number one. If you are all not able to understand, if anyone not able to, then I can re-explain. Otherwise, I'll move with question number two. Please, anyone, if you're not got, please write in the comment. Everyone got? Please at least write say yes. So I'll, because I don't know whether I was during the explanation my network was connect or not. Okay, Abdul is telling yes. Okay, good. Okay, if anyone not have any doubt, then we'll move on question number two. The question number two is yes. Okay, here the answer is visible. So here the dynamic equation of gradually varied flow is based on the assumption that the equation of your gradually varied flow is dy by dx is equal to dE by dx divided by 1 minus fr square. Here dE by dx is s naught minus sf. Remember please, that is the change in energy with respect to distance. Okay, so or you can say the specific energy, not energy, specific energy. So actually in the derivation, we assume the pressure distribution hydrostatic. Here is non-hydrostatic, so this statement will air interment not considered. Roughness coefficient are depend on the flow depth. This is also wrong. So that's why none of the above. Now we'll move on the next question. Next question is question number 3. Very important question. Yes. The value of specific force at two flow depth y1 and y2 in a natural open channel is same. Then the depth y1 and y2 are called second depth, alternate depth, either of both, none of the above. Which option will be correct for question number 3? Everyone please write your answer in the chat box. Okay. So okay, for question first, C answer, okay, but for 3, question number 3, please write your answer for question number 3. The value of means at two depth your specific force is equal. Remember the terminology, very very important. Sometimes direct questions come from these topics, that is your gradually varied flow and your rapid varied flow. I have the 2 year, that is the your, okay, Abdul is telling a second depth. So I have actually the two sets, one from 2024 and another one 2023, hydraulic engineering and PTL. So Downal, okay, you are also telling A option and Abdul also. Yes, A will be correct. For alternate depth, the your specific energy should be same at two depth. Then you can go through the alternate. The answer will be alternate. But here is the specific force. So your option A will be correct for question number 3. Now we'll move on question number 4. The question 4 is total number of possible type of GVF profile. Total number of possible. So please everyone write your answer. Total number of possible GVF, gradually varied flow profile, are 12, 5, 6, 10. So actually we have the 5 types of slope. First one is your mild slope, second one is steep slope, third one is your critical, and fourth one is your horizontal, and fifth one is adverse. In 5 type of slope, how many profile you have? Whether 12, 5, 6 or 10. Just for as a hint, I have given you the 5 type of slope we have in hand. Okay. Abdul is telling A option 12. Other student, please also try to write your answer. As you have joined here, then it means you need to give the answer. And for week 6, I have already recorded the video. You please go through YouTube channel as well as whatever the spreadsheet, the log sheet you will be provided. You can go through also the log sheet. I have given the link and also uploaded the material in the Google form. There's a Google folder, I think. Please everyone write your answer. Only Abdul is telling option A for question number 4. Other student, please also write your answer. Okay. So let me explain little bit. So actually in GVF profile you have 12. Yes, option A is correct, but how? We have the 5 type of slope. One is mild, second is steep, third is your critical, fourth is your horizontal, and fifth one is adverse. Mild is like that, steep will be very like that, critical you may assume like that, and horizontal complete horizontal, and adverse slope will be just opposite. All slope in this direction, but the slope in this direction, not flow. I am not showing here the flow, the slope direction in this. So we have here the 3, and here also 3, here 2, and here 2, and here 2. So 6 and 6, 12. How? You please, for this you need to go through detailed video whatever sir have taught already in your course week 7 content, so you can get a very clear concept about the 12 profile of GVF. Now we'll move on question number 5. Question number 5 is, in GVF, as the value of water depth approach the uniform depth. or you can say the normal depth. The water surface meet the normal depth line vertically, meet the very large depth as a horizontal asymptote, approach the normal depth line asymptotically, none of the above. Which option will be correct for question number 5? Everyone, please write your answer in the chat box. For question number 5, in GVF, as the value of water depth approach the uniform depth, the water surface approach, that is meet the normal depth line vertically. Option B, meet a very large depth as a horizontal asymptote. Option C, approach the normal depth line asymptotically. And option D, none of the above. Which option will be correct for question number 5? Everyone, please write your answer. These are the very important question. Okay. C, approach the normal depth line asymptotically. Yes, you are correct. So, as the value of water depth approach the uniform depth, approach the normal depth line asymptotically. Means, if I consider the mild slope here, so this is your critical line, this is bed, this is your critical line, and this is your normal line. Normal depth line you can say also. So, here is you meet your asymptotically, means like that. Right, remember. Option C will be correct for this. For question number 5, option C will be correct. Now we'll move on the next question. Next question is question number 6. The following type of JBF profile do not exist. Does not exist. C2, A2, H3, M1. For question number 6, please write your answer in the chat box. Very easy question. Following type of JBF profile does not exist. Okay, Abdul is telling C2. Other participant also try to write your answer, please. Everyone, please. For question number 6, everyone please write your answer. Abdul is telling C2 means option A. But other student, what about the other students? Okay, D, M1 you are telling. Tanal is telling option D, M1. Okay, you are telling C means H3. Okay, not D, H3. Okay. So actually, C2 not possible. Anyone want to write your answer? Then I'll explain. Okay, no one. So let me just discuss. So here answer will be your C2. How C2? Let me just because if your slope is that is critical, your NDL, this is bed, equal to CDL. Critical depth and normal depth will be same. So this is bed, this is your critical depth, and this is your normal depth line. So this is 1, this is 2, and this is 3. So 2 is the 2, that is zone 2 in between NDL and CDL. So here NDL and CDL is same, so zone 2 will be not possible, but above the NDL is 1 and below the CDL is 3. So NDL CDL is same, so here 3, but 2 is not possible because 2 is in between the CDL and NDL. So hope you all got it. Question number 6. Now we'll move on the question number 7. Question number 7 is the post jump fruit number in a horizontal trapezoidal channel is post jump fruit number. Post jump fruit number in a horizontal trapezoidal channel is less than unity, equal to unity, more than unity. That is more than, less than, unity means 1, none of the above. Which option will be correct for question number 7? Just think please. For question number 7. Okay, less than unity. Other student, please also try to write your answer. Question number 7. Here we are talking about post jump fruit number. So you have to think after the jump whether flow is critical, subcritical, or supercritical. Based on that, you give your answer. Just for hint of question number 7, I have given you. So now you can please rethink everyone and write your answer again. Whether after the jump, whether flow is subcritical or supercritical. Just think on that first. Based on that, you can write your fruit number. As you all know, for supercritical, your fruit number greater than 1. For critical, equal to 1, and for subcritical, less than 1. So based on that, you try to write your answer. Please, everyone, write your answer, please. Okay, Mangal Chand is telling option A. Okay, less than unity. Okay, let me just discuss whether A and B, which option will be correct. So just think, after the jump, for hydraulic jump, your flow need to go through two phase, supercritical to subcritical. Means if I write here supercritical and here subcritical, subcritical, and here is hydraulic jump. So this is pre and this is post. If these two conditions will happen, then only possible hydraulic jump. So before hydraulic jump, your flow should be supercritical and after that subcritical. So here question is asking about post jump, means after. Means subcritical Froude number less than 1. Supercritical Froude number greater than 1. And for critical, Froude number is 1. So here we are talking about only post. So your Froude number will be less than 1. Option A will be correct for question number 7. Now we'll move on the question number 8. Very important question. Okay. A hydraulic jump take place in a 0.6 meter wide rectangular horizontal channel. Rectangular horizontal channel, remember please, horizontal channel means theta will be 0 degree. Rectangular you all know. At a point where the flow depth is 0.16 meter and flow number 2.4. Specific energy at that point. You need to calculate specific energy. So everyone please try to first understand the question, then after try to solve the question. Everyone please. Very important question. Actually very fundamental and basic question. So everyone please try to first understand, then try to calculate. So everyone please try. You have another 2 minutes, then after I'll explain. Okay, let me discuss. So here actually we have a rectangular channel with theta 0 and 6 meter wide, 0.6 meter, where the flow depth is 0.16. The fluid number is given 2.4. Specific energy at point. Specific energy is equal to Y plus V square by 2Z for theta is equal to 0 and hydrostatic pressure distribution. Based on these two assumptions, your specific energy will be like that. The formula. So Y is given 0.16. V is not given. So you know Fr is equal to Vy. For rectangular channel it will be Y. Otherwise Fr is equal to Vy root G A by T, or you can say D is equal to A by T. So here you can put the T. Okay, that is a hydraulic diameter, not hydraulic depth. Okay, we have the question. So we'll clear the terminology later. So here is, you can calculate V 2.4 into G into 9.81. So V is how much? Please anyone write the answer. V is how much? Please anyone write. What is the value of V? Please just calculate and write in the chat box. Or let me just calculate. So 9.81 into 0.16 is equal to root over into 2.4, that is 2.68 velocity. Okay, final answer you are telling 0.62. Okay, let me just check. So 2.68 velocity meter per second. Here you can write 2.68 square divided by 9.81, 2 into 9.81. So divided by 2 divided by 9.81 plus, oh sorry, 2.68 square divided by 2 divided by 9.81 calculation is wrong, I think. 2.4 into 9.81, that is G value, and Y value is 0.16. This is your Y. So how much? 2.4 into, let me just, 0.16 into 9.81. Okay, and square root 1.25 into 2.4. Oh, it will be around 3, right? So now square, that is 9 divided by 2 divided by 9.81 plus 0.16. Okay, 6.2, yes. So 0.62 meter. So remember please, the calculation may be wrong, but yes, option is 0. Now calculation is correct. So option B will be correct for question number 8. Now we'll move on the next question. Next question is, yes, in the above problem, if the post jump flow depth is 0.47 meter, then the energy loss associated with the jump is energy loss. Here is the post jump flow depth is given. Pre jump was given previously 0.16 and post jump is given 0.47. Now you have need to calculate energy loss. Very important. So in the previous, that is in week 6, I have discussed about the formula and all of energy loss, but here you need to write first your answer for question number 9. Everyone please, you have another, you have 5 minutes, please try to just remember the formula and write your answer. Okay, Abdul is telling D option. D means none of the above, you are telling, right? Okay, I'll see. I'll see. So what is the final answer? What is your answer is coming? Please, Abdul, write your answer in the chat box. If you are getting none of the above, but how much? What is the magnitude? Okay, 0.245. Other student, please also try to write your answer. Okay, you have a another next 1 minute. Then after I'll discuss. 1 minute more you have. Okay, let me just discuss. So here is, you have two depth, that is y1 and y2, and energy loss formula is y2 minus y1 whole cube divided by 4y1 y2. So let me just put 0.47 minus 0.16 cube divided by 4 into 0.47 into 0.16. Now you need to calculate. Let me just calculate. So 0.47 minus 0.16 cube. Okay, sorry. 0.47 minus 0.16 cube. It is coming 0.02979. Okay. Now 4 into 0.47 into 0.16. So 0.3008. Now I want to just 0.02979 divided by 0.3008. So it is around 0.099. Means 0. So whether, so I think option A will be correct, or maybe somewhere I am doing mistake. 0.47 minus, let me just recheck, 0.16 cube 0.0297, yes, correct. 4 into 0.47 into 0.16. Yes, I'm correct. So here answer will be, I think, yes, D, but your answer, yes, we are getting this one, 0.99. Okay, calculation is correct. I was thinking option A will be correct, but here calculation is correct, so none of the above. Option D will be correct. So please recheck your Abdul, your that is your final calculation. But your option was correct. Sometime such kind of thing happen. but you need to check your calculation. Now we'll move on the next question. Question number 10. Question 10 is the fruit number at the end of hydraulic jump in a rectangular channel is 0.25. The second depth ratio of the jump is very important. So please try to calculate. Option A 2.5, B 5.2, C 8.9 and D 9.8. Which option will be correct for question number 10? Here you have the fruit number at the end of hydraulic jump. At the end of hydraulic jump in a rectangular channel is 0.25, the second depth ratio. Very important. So everyone please write the answer. Try to first solve the answer. Question number 10. So please everyone try to calculate. So anyone want to write your answer? Please write. You have 1 minute, another 1 minute. So please write your answer quickly. Anyone, please. Okay, let me just discuss. So here is you have the fruit number is given after the at the end of hydraulic jump means after the your jump, that is FR2 is given 0.25. So you have the second depth relationship y1 divided by y2 is equal to 2 root under 1 plus 8 FR2 square minus 1. So this is the formula. So now you can very easily calculate 0.5 1 plus 8 into 0.25 square minus 1. So let me just calculate. You also please, everyone please calculate 2 5 square. Maybe my calculation will be wrong, so you have to write your calculation correct. 8 plus 1 square root minus 1 into, so somewhere I am doing mistake. Let me recalculate. 0.25 square into 8 plus 1 square root minus 1 into 0.5. So my calculation is 0.11. So please, you are telling 8.9. So actually I am using mobile for the calculation. Okay. Okay, if you are telling 8.9, so how it is coming 8.9? I'll check. Okay. Okay, you are telling y1 by y2. Okay, I have put it the y1 by y2. Okay, let me just see the calculation. Yeah, answer is 8.9. Okay, okay, okay. So yes, I was got this one. So 0.112. Yes, the calculation is y1 by y2 is 0.1123 I am getting. But here, if the answer is not matching, so you need to just write like that. You just check whether this matching or not. If this is not matching, then it means your answer is wrong. But if y1 by y2 is not matching, so let me just check y2 by y1. So just opposite 1 by, so 1 divided by 0.1123. Yes, it is 8.903. So you can write 8.9. So like that you need to check also, because here is asking about the ratio, depth ratio. No need, this it doesn't mean like that you need to give only y1 by y2. You can give also y2 by y1. So based on that you check your answer here. Okay, remember for future. Move on the next question. Yes. One thing also remember, please, very, very important. This formula is only valid for this formula. This formula is only valid for your rectangular channel. Remember, this is not valid for your any other like triangular, trapezoidal, not. This formula is derived only for especially rectangular channel. Remember always. Now we'll move on the next question. Next question is for a classical hydraulic jump analysis, the frictional resistance is assumed to be 0, unity, infinity, none of the above. For classical hydraulic jump analysis. So everyone please. Now I'll take the 5-minute break and everyone please try to write the answer for question number 11. Okay, now let us start. So the classical hydraulic jump analysis, the frictional resistance is assumed to be here is 0 because of the your in hydraulic jump actually happened within a short span of length, so we can neglect your frictional resistance. In the derivation actually we neglect for simplification. And classical hydraulic jump means in rectangular channel, jump in rectangular channel. Okay, next question. Question number 12. The mathematical analysis of hydraulic jump is based on conservation of kinetic energy, total energy, linear momentum, all of the above. The mathematical analysis of hydraulic jump. Please everyone. For question number 12, everyone please write. D, all of the above. Okay. Amit is telling all of the above. Other student please. The mathematical analysis of hydraulic jump. Okay, Anurag is also telling D option. All of the above. Anyone want to write? Then after actually we have only 12 question in this set. Another set I have also. So we'll solve another 12 questions. So okay, Mangal Chand also telling D. So actually in hydraulic jump, during the derivation, the energy not conserved. Why? Just for example, let us suppose jump is happening. So here is energy is not conserved because of in the jump energy losses. So we will not use the total energy concept for the derivation. We only we have the linear momentum concept for the mathematical analysis of hydraulic jump. We cannot use the energy concept. Remember always please. Why? Because of the loss in energy during the hydraulic jump. So we don't know how much loss. If we don't know how much loss, then how can we apply the energy concept here? So we'll use linear momentum concept. Remember always. So now let me just question 1. Oh, I think not visible. Okay. Whether it is yes. Okay, question 1 is visible. Please everyone write. Anyone can
Yes.
write. Okay, okay. Okay, fine. So the question 1 is, if the value of rate of change of a specific energy 7.03 into 10 to the power minus 4 meter, the and SF, that is slope, energy slope is given 0.00013, calculate the value of bed slope. So here you need to calculate the bed slope value. So just in the previous set of questions I have told you the equation of gradually varied flow. In equation of gradually varied flow, I have discussed about the rate of change of a specific energy and formula also. So please just think and try to calculate and write your answer in the chat box for question number 1. Important question. Everyone please. Okay. So the formula is S naught minus SF. Now please you need to calculate S naught from here. Please everyone try to calculate for question number 1. Everyone please. So how much? Please anyone can write how much S naught is. Okay, C option. Good. So let me just, yes, option C is correct for question number 1. Now we'll move on to question number 2. So question number 2 is when the hydraulic jump is in a moving form. Moving form means the hydraulic jump, it is called negative surge, positive surge, turbulent surge and accelerated surge. Moving surge means let us suppose a bed, and moving surge means if the surge is moving like that, moving in the flow line. So like that. So whether it is positive or negative or turbulent or accelerated. So please write your answer for question number 2. Okay, D option accelerated. Other student please, C option turbulent surge. Other student please. Manoj is telling C. Abdul is telling B. D. Anyone? Okay. So the answer of this question is, so the when the surge is moving and if it is increasing the depth then positive, and if it is decreasing the depth then negative. So when it is moving, that time moving form means the moving in this direction, moving is like that. So it means positive surge. Remember please. For question number 2, your B option will be correct. Next question. The fluid height before the hydraulic jump. The fluid height before the hydraulic jump is normal, low, high, zero. The fluid height before the hydraulic jump we are talking about here, before, remember. Before the hydraulic jump. Please everyone try to write. Before the hydraulic jump you are telling option A, Manoj. Low, okay. Amit is telling low, okay. Abdul is telling B, low, yes. Other student please. Before, because you know already for hydraulic jump you need to have supercritical flow. Your flow should move from supercritical to subcritical. Then in supercritical whether flow is low or high compared to subcritical, think on that and try to write your answer. Okay, most of the student telling B option, low. Other student, anyone can write. Other student please also you write your answer. Okay. So yes, the flow depth will be low compared to your post jump. Okay. Here is answer is C, but answer is wrong. Not answer will be B. Remember please. Low. In the description is written very well. The fluid height after the hydraulic jump is high. The fluid height after the, but here question is telling before. So maybe typing mistake here. Option B will be correct. Now we'll move on the next question. Okay, here answer is, as you can see, the energy is not conserved throughout the hydraulic jump. Yes, as I have discussed just few minutes back, the energy is not conserved throughout the hydraulic jump because some energy losses in the jump. So yes, it is correct. Now, next question. Yes. Okay. Next question is calculate the mean hydraulic depth of channel. Mean hydraulic depth, remember please. What we were talking about previously, Fr is equal to V by GD, that is D is equal to A by T. This is your hydraulic depth, mean hydraulic depth. Remember please. Having top width this and cross sectional area is this much. So mean depth your will be definitely area by top width. Area is how much? 35 and this is 7. So answer will be 5 meter. Next question. Question number 6. What is the Froude number for a channel having mean velocity is 4.34 and mean hydraulic depth is this? So you need to calculate Froude number. Please everyone write your numerical value in the chat box for question number 6. Very easy question. Just please You just think and write your answer. Just think and calculate and write. Very easy question. Everyone, please. 0.8. Abdul is also telling and Manoj is also telling 0.8. Okay. Other student, please also try to calculate. So FR is equal to, as I have written here, V is equal V divided by root GD. D is your mean hydraulic depth. Remember, depth, not diameter. Mean hydraulic depth. So velocity is given 4.34 divided by root 9.81. Depth is already given. Hydraulic mean depth is 3. Means, let me just calculate, 9.81 into 3 square root 5.425. 4.34 divided by 5.425. 0.8. Yes, the FR is 0.8. Remember, please. Now we'll move on the next question. Question number 7. Calculate the mean hydraulic radius. Here is mean hydraulic radius you need to calculate for a channel having 20 meter square cross sectional area and 50 meter of weighted perimeter. Mean hydraulic radius. Very easy question, please everyone. 0.4. Okay. Other student, please. Very basic question from open channel. Mean hydraulic radius. Okay, Abdul is only telling 0.4. Other student, please also write your answer. So here I'll tell you the one thing, another one thing, mean hydraulic radius and also hydraulic diameter and mean hydraulic depth. Three things I'll discuss here in this question. Very important. And also I'll discuss about little bit Reynolds number in case of circular pipe and in case of your open channel. In elaborative way, I have written, actually I have explained in week number 6. the recorded video. But here I'll explain because here term is mean hydraulic radius. So please other student also write your answer for question number 7. Okay, Manoj is also telling 0.4. Okay, I think you all are correct. So mean hydraulic radius is if I represent with R, or sometimes people represent with HR. So the formula is weighted area divided by weighted perimeter. So weighted area is given 20 and weighted perimeter is given 50. So here you can calculate very easily 0.4 meter. What is weighted area? Weighted area is nothing but if this is channel and this much is water is flowing, so these are the area. These are area is weighted and above area is dry. So we will not consider above area. This area is weighted. So we will consider this area only. If channel is like that and only water is this much, so we will consider this area only, weighted area. And perimeter also weighted perimeter, whatever the your surface is wet to the liquid, so that surface only we consider as a perimeter. This, if this is 2, this is 3, this is 2, so your perimeter will be 3 plus 2 to 4 means 7. So like that you will calculate perimeter. And area you know already, area means depth into width means 6. Okay, so hydraulic mean radius you know already this one, and hydraulic diameter, that is HT, is equal to 4a by P, and hydraulic mean radius, weighted area here you can also write, and hydraulic mean radius is equal to AW by AP. So the relation between HD and HR, HD is equal to 4 times HR. Remember please. Means your hydraulic diameter is 4 times of HR. Normally your diameter is 2 times of radius, but in case of open channel, remember please the terminology, the hydraulic diameter 4 times of your hydraulic mean radius. Now, and hydraulic mean depth capital D is equal to your area by top width, and Reynolds number in case of your circular pipe, rho average velocity into D. D means here, let me write the small d. D is the diameter of your pipe by mu, dynamic viscosity. And in case of open channel, rho V HR, or you can say R only, that is hydraulic mean radius. Rho V average into HR divided by same thing. Remember please. So these are the concept. That is the fundamentals of your open channel. Okay. Now we'll move on the next question. Question number 8. Okay, this is also important. When the energy is at minimum for a load flow discharge is called normal depth, roughness, critical depth, hydraulic radius. Very important. So here I'll explain a little bit about specific energy and depth curve. But before, try to give your answer. When the energy is at minimum for a flow discharge, it is called normal depth, roughness, critical depth, hydraulic radius. C option, critical. Okay. Abdul is telling C, that is critical. Other student, please. Other student, please also try to write your answer for question number 8. Another 1 minute I'll give you. Then after I'll explain. Okay, Manoj is also telling critical depth. Yes, critical depth is correct. So let me a little bit discuss. So a specific energy you know already, Y plus, actually little bit discuss from your total energy. Total energy is nothing but datum head plus pressure head plus your velocity head. But we assume the pressure distribution is hydrostatic, rho g h, or rho g y, you can say depth of the flow. So your h will be z plus y, that is rho g will be cancelled out, and v square by 2g. Specific energy is nothing but, so here z is a datum. So if we consider the z is equal to 0, means the datum we have considered bed of the channel, bed, sorry, the datum is bed, means z is equal to 0. So a specific energy will remain y plus v square by 2z. So here when you will draw on curve, that is E and here is Y, means one equation you have, that is one plot you have like that, a straight, and another you have parabolic, that is v square. So after combining this, you will get, after combining, you will get like that. This is your complete straight line. After combining, you will get this graph only, not this one. Dot dot, just I am showing you for just your visualization point of view. You will get like that. Remember. So here is E and here is Y. So E is increasing in this direction and Y is increasing in this direction. So let us suppose here is E1, here E2, means your E value is reducing in this direction. So like E3, E4. So at E4 you have two depth, this one and this one, that is Y1, Y2. Similarly E5 up to here, this is your, up to this point you have only one depth, this depth, that is critical depth. This depth we know critical depth, and here is velocity, your energy is minimum. After that, if you will reduce the energy of your flow, what will happen? There is no flow, no depth. If you have reduced, that is energy minimum, let us suppose after that you have your energy is here, E dash, then what will happen? There is no depth, so means flow will not happen. So minimum energy is at critical depth, like that you will understand. So hope you all got it, the concept of the critical depth. So for question number 8, your option C will be correct. Anything else? No. Okay. And here one thing more I want to tell you. Let me draw very clear. So if this is critical, YC. So for a particular energy, except critical energy, except minimum, you have two depth. This is your Y1, that is here, and this is Y2. So before this, your supercritical flow, and above this critical line, whatever the flow. Here also, if the flow depth is here, then subcritical. That is your subcritical. If flow depth here, then the flow is supercritical. So this is your sub, right? Now the fluid number here will be greater than 1, and here fluid number will be less than 1, and up to the critical line, that is at critical line, if FR will be 1. That is critical flow. Remember please, only one critical flow possible for rectangular channel, such type of channel. Maybe two, sometimes two critical, three critical flow possible, but for different compound type of channel. But for such type of channel, only one critical flow possible. Okay, now we'll move on the next question. Next question is question number 9. The calculate the maximum discharge through a triangular channel having a side slope 1 is to 2 vertical, 1 horizontal, 2 vertical, and critical depth 3 meter. The maximum discharge here you need to calculate. So everyone please try to calculate the maximum discharge. Yes, one thing I forgot. This line, the energy line, whatever you are drawing, this line is only for a particular discharge, only for constant discharge. When you will change discharge, maybe line will shift. When you will reduce or increase, the line will be shift here and here. It's depend. Okay, so this was the things. Now calculate the your maximum discharge for a triangular channel for question number 9. The side slope is given 1 is to 2. 1 horizontal, 2 vertical. Everyone please. Okay, I'll tell you the concept. So here the triangular channel, and flow depth is given 3 meter. This is given 3 meter, and you have the your slope means one horizontal, two vertical. When you will move three vertical means when you are moving two vertical, you are moving one horizontal, or one horizontal two vertical, whatever. When you are moving three, then how much horizontal? 1.5. Here also 1.5 means now for critical depth means Fr is equal to 1 divided by V root G A by T, right? And discharge is equal to velocity into area. So velocity is G A by T. Here is velocity. If you will calculate from here, V is equal to root G A by T into area. So area is half B. B is 1.5, 1.53 into depth 3. So 4.5 meter square, and top width is equal to 3, 1.5, 1.5. Now you can calculate 9.81 and 4.5 divided by 3 into 4.5. So hope you will get the answer. Let me just show you. 17.26 meter cube per second. So C option will be correct. Now next question. Question number 10. The critical depth and base width of a trapezoidal channel is 2 meter, 5 meter respectively. Critical depth as well as base width is given, and calculate the maximum discharge. Here also you need to calculate maximum discharge if the side slope of the channel is 1:2. Side slope is given 1:2, and here is depth is both side 1:2. Here diagram is not correct, but just think. Okay, let me redraw. Here is 1:2, and critical depth is given 2 meter, and base width is 5 meter. So you need to calculate U max. Similar formula you will apply here. So critical depth means Fr will be 1. So velocity into G A by T. So discharge will be G A by T into your velocity. Velocity is this one, and into area. So how much area? Area is, if let us suppose this is T, top width. So area is half into T plus 5, this one, into depth 2. This is area. And what is top width? Top width already you know already. Top width is T. T is, but how much T? But how much T? So again, when you are moving two vertical means one horizontal. So here, one here and one here. Already 5 is given, 6, 7. So T will be 7 meter. So now you can very easily calculate your discharge. G, so 2 will be cancelled out and here will be 7, 12 meter square. So 9.81 into area 12 by 7 into 12. So now you can calculate Q max very easily for question number 10. Hope you got it. Now next question is, okay, the hydraulically economical section of drain for large flow is whether V shape, oval shape, rectangular shape or circular shape. Here option is D, circular, but V shape when you will use when the flow is low. Rectangular for medium flow or moderate flow. Oval shape we use for little bit more and circular shape for high flow. Here explanation is given. When you drain will consider in the over and the flow, then you can go for oval. Let me just show you. Yes, V shape section is usually used basically for low discharge, generally present in valley. Rectangular section is used for medium discharge. Oval shape section is used for combined sewer, that is your rain as well as your means rainwater as well as your domestic sewer, whatever domestic waste, domestic liquid waste, not all waste, solid waste. And circular section is suitable and economical for large flow. So question was about hydraulically the economical section of drain of large flow is your circular section. Next question number 12. Okay, so determine the section factor for the channel section having area is 20 meter square. Please everyone, section factor for question number 12. So here I'll tell you two concepts. One is conveyance. What is the conveyance of flow and what is section factor? I'll explain two things. Section means, as name suggests, the things will be related with section only, that is your cross section, that is top weight and that is width or depth you can say, and flow conveyance is related with your something convey. Okay, we don't have time, so let me just discuss. So the section factor is nothing but Z is equal to A root A by T, and your conveyance is discharge is equal to area into velocity 1 by n r to the power 2 by 3 s to the power 1 by 2. So your conveyance factor will be this one, the whole k s to the power 1 by 2 q. The conveyance is a 1 by n r to the power 2 by 3. And how this come? Jet section factor. Let me just, and here top width is given, the missing value. Top width is missing in the question. So the question is incomplete. Question is not complete. So but how it come? So you know Fr is equal to velocity by Gy or Gt. For critical flow, V is equal to G A by T. So for discharge, let me just convert this velocity as discharge. So velocity is equal to Q by A. So Q by A is equal to G A by T. So let me just put all the your section things in one side. So Q divided by root G is equal to A root A by T. So this value we put generally as Z by Q by root G. So after square, Z square, Z square divided by Z square is equal to Q square by G. So remember please. So section factor you can write like that also and like that. So hope you all got it, the concept behind your section factor and conveys. So thank you all. We'll meet in the next class again on I think 14. Okay, thank you all. Please now you can leave the class. Okay, thank you. Now everyone can leave.